Thank you for bringing that up. Gentlemen and ladies, shh. On your tracking sheet, you see this skill as proving that a quadrilateral is a parallelogram. In your notes, it's entitled Proving Parallelograms. Yes, we are talking about the same thing. So, first of all, I am reasonably confident that the title of today's notes caused at least an inward cringe. Oh, not this anymore. There's not so much of actual proving that something is a quadrilateral, but rather looking at a quadrilateral, looking at the markings therein, processing what we know demands that a quadrilateral will be a parallelogram, and then identifying, is this a parallelogram or not? Okay, so very little actual doing a proof, if that's any relief to you. All right, so Tuesday's lesson, we talked about the properties of a parallelogram. Let me rehash that. Properties of a parallelogram, recall where that opposite sides were congruent, opposite angles were congruent, consecutive angles were supplementary, and that diagonals bisected each other. The converses of all of these statements are true, as you can see on the screen. Remember what converse is. Converse takes a statement, an if-then statement, and then does what with it? Flips it around. So Tuesday's lesson all started with if it is a parallelogram, then property. So today's lesson, flipping all of those properties around, what we're looking at is if this property exists within a quadrilateral, then the quadrilateral is a parallelogram. Okay, that's basically it. So all of these statements, all of these ifs on the screen have the same then, which you just identified. Then, there we go. Twice, because two thes are twice the time. Let's type this. Maybe that'll work faster. For Christmas, Santa's going to get me a faster computer. Then the quadrilateral is a parallelogram. Oh my gosh. Okay, you have it in your notes. I don't need it on the screen, right? I can move on? Yeah. The quadrilateral is a parallelogram. Here we go. There is, it's your notes. As long as you can study from them, that's what's most important. So if you write down in your notes quad and you know exactly what it is, then it works. Okay? Absolutely. Okay, so let's look at some of the examples comparable to what you'll encounter in your notes, or in your homework. And the diagram on the screen, you may notice, looks very much like the kinds of problems that you've already seen in Tuesday night's homework. I have a figure, sure looks like a parallelogram. I have some measurements on there, and they're asking me to solve for the variables. The only difference is that on Tuesday's assignment, the instructions were, this is a parallelogram, solve for the variable. Here, they're saying, solve for the variable so that it will be a parallelogram. The basic idea is still the same. You're using the fact, for example, in this problem, that opposite sides of a parallelogram are what? Congruent, equal, whatever, in order to set up the equation and solve for your variables. Now, looking at the parallelogram and mentally realizing what equations you're going to set up, can someone tell me what equation I want to solve first? One person, please. You can look at the diagram and kind of mentally come up with what the two equations are. One of them is much easier to solve than the other. Lily. Absolutely, yes. Notice this equation that I would be setting up with the 4y minus 3 and the 2y plus 5, that's only got y in it. Whereas this equation would have an x and a y in it. Leave that one for last. Let's figure out what y is first. So our equation then is 4y minus 3 equals 2y plus 5. Easy to solve. Subtract the 2y from both sides, we have 2y. Add the 3 to both sides, we have 8. And y is 4. And once we know what y is, we can take that and plug it. Good, thanks. Okay. 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 Bye. Let's see if we need to go through this room. She didn't say, just to be on the safe side, go ahead. All right, so from here, we're going to take this 4 and plug it in this 5y expression. I know that the length of st, therefore, is 20. From there, very easy to solve for x. Our equation becomes x minus 8 equals 20. My screen never wakes up. Oh, that's an x plus 8? Thank you. So, x equals 12. And we have solved for those variables. Did the instructions want us to go and plug it back in? You tell me. No. The instructions were only asking us for what value of x. So actually, they didn't want the answer for the y, but you needed to figure out what y was in order to figure out what that x was. Good on this screen? Take a moment to work through the your turn problem 1, please. Okay, based on what I'm seeing and hearing, I want to go over this one whole group. What most of you understandably jump to is, okay, I know opposite angles of a parallelogram are congruent. Let me set those equations up. However, when you look at the equations that you end up setting up, they both have both x's and y's in them. Ew. If at all possible, I'd like to avoid solving a system of equations. It's just easier to solve one equation in one variable. So this is where you need to move on to what else you know about angles in a parallelogram. Yes, the opposite angles are congruent, Michael. Right, remember consecutive angles are supplementary. So these two y angles, they add up to 180. Same thing with these x angles. They add up to 180. And the problem is asking me for both variables, so we got to solve both of those equations. 3y minus 2 plus y plus 10 equals 180. And 4x plus 13 plus 12x plus 7 equals 180. Like I'm writing with invisible ink. Here it goes. Combining our like terms for the y equation, we have 4y plus 8 equals 180. 4y equals 172. So y is what, 43? What's that? 43. And then for the x equation, combining our like terms and solving, we have 16x plus 20 equals 180. Subtracting the 20, 16x equals 160. And then x is 10. Yes, ma'am? You could. You absolutely could. And in the end, you would have ended up in the same place as we did. However, this equation, 3y minus 2 equals 12x plus 7, is neither in standard form, which is how we normally look at the equations when we're using elimination, nor is a variable by itself. It just would have been a real pain in the neck. Okay? Absolutely. If you really love solving systems of equations, go right on ahead and do so. But if it's possible to set up one equation in one variable, why not do it the easier way? Okay? Any other questions on this one? Let's do it. Okay, as I said, there's not a whole lot of actual proving that something is a parallelogram, but rather quite a bit of look at the markings, look at the information. Can I prove that this is a parallelogram? So, in problem 2, part A, based on what you are given, can I conclude that this is a parallelogram? Look at the markings, or look at the information, and perhaps use the information to put some markings in the diagram. So, AE is congruent to CE, and the length of DB equals twice the length of DE. So, if BD equals twice DE, does it make sense that I can put those markings in place? Based on the markings I have on the screen, can I say that this is a parallelogram? And if so, what property are we using? Can we say yes? Beautifully put, yes. This is a parallelogram because the diagonals bisect. In part B, yes. I'm sorry, say that again? How do I know that they're equal? Because they're telling me that the length of DB equals 2 times DE. In other words, another way to put it is that DE is half of DB. Well, where's the other half? EB. You're good? Okay. In part B, let's take the information that we're given and put it in the diagram. I have that Y is 49 degrees. I have that Z is 131. And that W is 49. So, is this a parallelogram? And if so, why? Jesse? Why? Okay, but so far I only see one pair of opposite angles that's congruent. Tell me what thought process led you to the statement that you made. You're not wrong, but I want a little bit more information from you. No, I don't have vertical angles here. You have to pass that baton. Your heart was in the right place. Eugene?
Quadrilaterals equal 360 degrees.
Right. Remember that the angles in a quadrilateral have to add up to 360 degrees. So hopefully the math that Jessie did without even realizing it was to add the 3 angles that she knew, subtract them from 360, and find that that angle was also going to be 131. Without doing that math, however, you still could have said that this was a parallelogram because the consecutive angles are supplementary. Yes. Okay, so yes, because angle Z is supplementary to both consecutive angles. And I do apologize, my handwriting is normally already bad, and then I can't see where I'm writing, so it's getting worse. We have from this screen what we need. Okay, take a moment and work through the your turn problem 2. I just realized that there's one additional property that wasn't on my screen, but it is in your notes, but I didn't talk about it, so I want to make sure to talk about it. Actually, it was on the screen. We just kind of glanced over it and didn't address it. Notice in your notes you also have this one other means of proving that something is a parallelogram. If one pair of opposite sides are both congruent and parallel, That's also a way that we can prove that something is a parallelogram. Now make sure that you understand, make sure that you realize it's the same pair that has to be both congruent and parallel. Eyes up so you can kind of see what I'm saying doesn't work. Okay? You will get somewhere, you'll see a distracting problem where you have one pair of sides that's parallel and another pair of sides that's congruent. That's not the same thing. That's not enough. One pair has to be both congruent and parallel in order for us to use this last problem. Okay, so I apologize for not mentioning that previously. All right, let me quickly go over the your turn for problem 2. Part A, hopefully you realized, was exactly that distracting problem that I warned you about. You have one pair of sides given to you as parallel, one pair of sides given to you as congruent, and they're not the same pair. That's not enough. You don't have enough information to say that this is a parallelogram. In part B, I heard some wonderful observations. I heard the phrase alternate interior angles. Yes, the angles that are congruent are alternate interior angles. And if you remember from way back in chapter 3, if alternate interior angles happen to be congruent, you can use that to show that lines are parallel. So you could, as far as a reason here, yes, this is a parallelogram. If we wanted to be as thorough as possible, we would say the converse of alternate interior angle theorem, which tells us that the lines are parallel, and then that makes this a parallelogram just by definition of a parallelogram. Yes, ma'am. Okay, notice the angles marked with one arc. Notice that they're on opposite sides of transversal LN. Notice that they're inside of lines AL and ND. Gentlemen. In order, if the markings weren't given to us, the angle markings weren't given to us, we would not be allowed to conclude that those angles are congruent. Yes, unless we knew that the lines were parallel. But remember, the converses of those properties told us if the angles are congruent, which they told us, then I can use that to conclude that the lines are parallel. Okay? Good on this screen. Okay, last problem in your notes, wildly, ridiculously simple, blatantly obvious, based on the fact that these are always 10 and these are always 5. No matter how high or low I raise the table, is the tabletop always going to be parallel to the surface it's on? Yes or no? Yes, this will always be a parallelogram. Eventually, it's going to start writing. There it is. And that's our whole lesson. The assignment is on the board. I noticed some of you already jumping to grab a book, take a picture of it. You have a few minutes to get started on the assignment. Has everyone taken the daily quiz?